So this is part one of engineering tools and equipment. So there's only 15 slides on this. You will need your engineering book to follow what I am saying. Please write any notes down, anything that you think will help you. Just remember that in the exam, there is usually a question that gives you a handful of tools. They ask you about their name and their uses, what you'd use this for and that. So it's essential that you watch this video and make sure that you take notes whilst doing it. So we are just starting on that engineering tools, machines and equipment. So designing and producing solutions to engineering-based problems involves the shaping and joining of materials that will in turn create physical products and items. To be able to begin the process of designing and producing components, engineers would need to understand how materials can be shaped and manipulated to create physical objects. This can be achieved by learning all about the tools, machines, and various items of equipment that can be used to create, as well as all the processes that materials need to go through to be changed into useful items. In this section, we'll be looking at a selection of common tools and machines that can be used in a typical workshop environment, using existing data to set machines to standard cutting speeds, modern day engineering with CAD/CAM, as well as some common electronic equipment that can be used to produce basic prototypes. So the first one's about hand tools. Clues in the name. Hand tools is everything that you use with your hands. So things like tin snips, screwdrivers, mallets, tenon saw, hacksaw, junior hacksaw, they're all hand tools. The main one that you start with is something that you will have used in the workshop here, was a vise. So a vise is something that you use to hold your work or to clamp it in place whilst you're cutting or whilst you're sanding, deburring. A metal vise is usually what we use within engineering, because a metal vise has a grip on there that can hold the metal in place, again, whilst you're cutting or shaping. Tin snips or shears, either or, I prefer calling them tin snips. So tin snips, also known as hand shears, are used to cut sheet metal by hand. So basically they are scissors for metal. The thinner the gauge thickness of the sheet metal, the easier it is to cut. If attempting to cut thicker gauges of sheet metal, then using bench shears or a hacksaw with a high number of TPI, so that's teeth per inch, is recommended. So if you've got anything thin, like aluminium, a thin sheet of aluminium, tin snips will be absolutely perfect for you. But honestly, they are just scissors for metal. Reamer. Now, a reamer is a cutting tool where you twist into an existing hole to make a hole on a piece of metal bigger. So you twist it, and ever so slightly, it will just create the hole, just making it a little bit bigger. As you can see, it's got a pointed edge. So the lower down it goes, the bigger the hole becomes. This gives it as well a really good finish. Deburring tool. So when materials are drilled or cut with a saw, there will often be a rough edge left behind. This rough edge is known as burr. Burr can be dangerous as they are incredibly sharp. A deburring tool can be used to remove any burrs, making your work safer. It can also be used to secure a better finish. There are different heads to the deburring tool as well, depending on what you want. But the deburring tool, think of it as getting rid of splinters from wood. You'd use sandpaper. If you want to get rid of metal burrs, which is very similar to splinters off metal, you'd use the deburring tool. Measuring tools, steel rule. I mean, I'm not going to talk too much about that because we already know everything about steel rules. What we also have is vernier calipers. Now, vernier calipers are for measuring instruments that allow the user to measure external measurement of workpieces, so diameters, for example. It will also give you internal measurement of workpieces, so hollow sections. So it will do the inside of a hole and the outside of a hole. Micrometer. Now, micrometer is a very, very accurate measuring instrument. It is used for measuring external. So you can see there where it says the anvil face and the spindle face. That is just the piece that you are trying to figure out the thickness of will be placed in the spindle and anvil face. It'll be twisted into place, and then it will just tell you, right, this is 0.3 millimeters. It can go to a 1/100th of a millimeter, so the lowest it will go is 0.01 millimeter, so it's extremely accurate. At the bottom there as well, where it says gauges, so gauges are highly accurate instruments that have been produced to gauge rather than measure a very specific size. Typically, gauges are known as go and no-go gauges. An example of this is a borehole gauge. The go diameter should be able to go into the hole or bore that has been produced. The no-go side of the gauge should not go into the hole. Right, looking at the next one, engineering square. Very similar to a woodworking square where you've got the stock and the blade. So an engineering square is a tool used in conjunction with a scriber to scribe perpendicular lines from an edge to check 90-degree angles. So you can use this to mark and to check 90-degree angles. It is not used to measure. Please don't make that mistake. I have seen that countless times. It is there to check a 90-degree angle, or with a scribe, draw a 90-degree angle. Combination square set, so very similar to the combination square. So a combination square set comes with a number of tools and options that are used to help check measurements and angles. As well as being used to help the user mark out dimensions on workpieces, they often come with spirit levels built in, so does the combination square. As well as a small scriber, which can be screwed from the bottom, to help you mark on hard surfaces such as metals. Each tool in the set can be removed or attached to the steel rule blade to perform different functions. So if you look on the left hand side there, you've got the corner combination set. You've got something that could give you a 30-degree angle or more, greater, because it's got looks very similar to a protractor there that you can change it. And then you've got the 45 and 90-degree angle, which is just on the right hand side there. If you look at the bottom of the combination square set, you will see like a spherical item just at the bottom of the stock. That's where the scribe is. You literally unscrew it, and there's a small pin there used for you to scratch onto metal. Combination square is very, very similar to the combination square set. However, it has a set dimension. So this only gives you 90 degrees and 45 degrees. It sometimes has a spirit level. To be fair, most likely does. The rule or the blade ruler can be slid back and forth. It's got a locking nut to keep the measurement accurate. At the front face, you've got a 90-degree face. On the back face, you've got a 45. And at the bottom, again, you've got that scribing tool. That's that knurled part right at the bottom there. That can be used to scribe metal. Okay, so next. So you've also got the center finder. The center finder attachment can be attached to the rule. You've seen this on the combination square set blade and used to find the center of circular objects. So if you want to find the center of a circular object, you can use them. So you've got the center finder there, lock nut, and the rule that slides there. Protractor, something that you use in school constantly. I will not waste your time with that. Right then, calipers. There are a few calipers to talk about here. So we've got the odd leg caliper, external caliper, and internal caliper. I mean, clues in the name. So calipers are used for measuring dimensions on workpieces. They can be set to specific measurements using tools such as steel rules and vernier calipers, and can be used to quickly check measurements. For example, if you want to remove material from a workpiece to a specific dimension, using calipers to check as you go is quicker than using a measuring instrument each time. So what they do is, so the first one is the odd leg caliper. It's very, very, very similar to a compass. You set it to the dimension that you want, and that will give you the same dimension over and over. It's almost like a template. So instead of you having to measure the same thing that you want to cut out every single time, you've got it on these calipers. So the odd leg calipers can be used to scribe, mark out parallel line from an edge at a specific or required distance. So if you set it at 50 millimeters, that will then scribe 50 millimeters all the way from the top of your material to the bottom. If you want to do it on another piece, that is still set. You can use the same thing. You don't have to measure, it's done for you. One side of the odd leg caliper will have a scriber attached. The odd leg caliper can also have a notched edge on one of the legs to make it easier to run down an edge of a workpiece. External calipers, well, obviously they're used to check the external dimensions of workpieces or materials. They can be set to a specific distance and used to check a workpiece whilst it is being worked on. So whilst you're working on it, so if you're sanding something down, for example, you want it to be a certain dimension. If you are turning something on the lathe, you want it to be a certain dimension. Those external calipers can be set to the dimension that you want. You check with that. If it doesn't fit, you keep sanding, you keep removing. Internal calipers, exactly the same as external, but it does internal instead. Right, moving on to dividers. So dividers can be used to check measurement, but are also used to inscribe arcs and circles on workpieces and materials, again like a compass. They work in a similar manner to a compass, but use a hardened steel scriber instead of a pencil. Scriber. A scriber is a tool made from high carbon steel, so it kind of looks like a toothpick, but it's made out of high carbon steel that you use to scratch metal, to mark metal. At the bottom here, we've got a surface plate. A surface plate is typically a cast iron bed that has been accurately flattened by machining, usually ground flat. It provides a flat surface which you can use to start marking out accurately. It is used in conjunction with other tools such as engineering square, V-blocks and scribing blocks. We'll be moving on to those blocks in a moment. Okay, so a scribing block. A scribing block is a tool used for checking measurement and more commonly used to mark out workpieces prior to shaping. It has a flat base, allowing it to sit on a flat surface for better accuracy. It also comes with an adjustable scriber to allow for accurate horizontal scribe making. On here we've got V-blocks that's used on any cylindrical or circular equipment. So if you want to cut out a metal bar, metal rod that is circular or tubing, you'd put it into the V-block. So it could be held in place, you twist the clamp onto your piece and you can use it to cut, mark and so on. Center punch, we've used a center punch in the past. So a center punch is used to mark the center point of a circle prior to drilling a hole. So you tap this with a hammer on the blunt end and then the sharp end goes into the metal and gives you a little divot. This ensures that when you are drilling through the metal that divot holds that drill bit in place. So when you're drilling through, it doesn't slide and slip everywhere. Dot punch, exactly the same. So generally the dot punch is the same as a center punch, however they are typically slimmer in size, so exactly the same as a center punch, only thinner. Ball peen hammer, so this is a hammer that has like a kind of ball at the back of it that can be used to shape metal. Again, you'd use the ball peen hammer to hit the center punch to make sure that you get those divots. Now flat files, something that